This session is all about the journey from initial idea to deployed Gen AI system. Now, we know that companies and organizations are increasingly worried about falling behind in terms of leveraging the power of generative AI. And if they are not already worried, there's enough media coverage to tell them that they should be worried about falling behind. So in a lot of cases, it's not clear how best to start on a Gen AI journey. So what we'd like to do in this session is to tell you about how 5 very different companies and organizations started out on their Gen AI journey and what they learned in the process. So I'm going to present the first 3 of our case studies, and then Miqdad Dali will come in and tell you about the remaining 2 case studies and also about how aiExplain support their clients in their Gen AI journeys through the services they offer. So jumping right into the first case study. So this is work that my group did with Dublin City Council. So these 3 case studies I'm going to talk about, they're all at different points in their journeys, which I thought would be a nice thing to do in this session. So the first one, we're right at the start. The background to this is, before I jump into that first case study, I was going to give you a quick overview of the different kinds of large language models that are typically in use these days. So let me do that first. So you know from John Keller's talk earlier what the landscape looks like. So these are probably the 3 most commonly used forms of LLM use. So we have LLM prompting, which is basically more or less what it says on the tin. You use a pre-trained language model like GPT, Llama, Palm, and obviously there's lots of others out there, out of the box, and you then prompt it. So a lot of the focus is then on the prompt engineering. How do you ask the right question to get the right output? Then we have LLMs and fine-tuning, where pre-trained language models are additionally trained on task-specific data. And finally, we have retrieval-augmented generation, where you combine the language model with different RAG tools and a knowledge base. There are at least three different ways you can do this, and I'm going to look at all of them very briefly in the first case study. There's also a question about how you access those language models clearly. So you can either access them served as a service, where your awareness of what changes under the hood may be limited. You also may be limited in your ability to protect your data that you're uploading, that you're putting in as part of the prompt. And there will be a substantial cost, which is proportionate to the size of your inputs and outputs and also your frequency of access. Another route you can go down is the open source route, and a surprising number of, in particular, public sector partners we're talking to are very interested in that route because it gives them the security, the confidence, and the control that they're looking for. So here, or you could even train your own, but that's beyond the feasibility, I'm guessing, of most of us. So in this case, you do have control over your model and your data. You don't pay for model access, but you clearly have substantial overheads in terms of expertise and system hosting, as well as maintenance updating. You also have to work out where you're going to be serving your models from. Are you going to do that from your own servers? Some organizations we talk to actually consider that. Or are you going to serve them from your cloud? So these are difficult questions. And the 3 case studies I'm going to be talking about, just briefly to pinpoint them in the default LLM technology stack that we have these days. So we have our instruction-tuned models, our dialogue trained models, and we have the tool-augmented models. So we have, in our 3 case studies, we have one of each. John told you enough about what the landscape looks like for me to skip the rest of this detail. Right, so now let's get to the first case study. So this is with Dublin City Council, and we're, as I said, right at the start of this particular journey. So the background to this is a challenge that the council face is that they are, like all public sector organizations, legally required to reply in Irish when an email inquiry comes in Irish. So they lack the capacity to deal with the volume they face in-house. So what they have to do is they farm it out to external translation services, which comes with a substantial time delay, which is a problem, but also substantial cost. So the idea here is that we create a Gen AI system to draft email replies based on the web space, the council web space, but also internal knowledge bases eventually. So we've just developed a proof of concept system for them, and I'll show you some outputs from that in a minute. And so it is a classic RAG task. So we can implement that very quickly these days using a bunch of out-of-the-box tools, for example, from LangChain. So at the moment, we're just using the public web space, and we're accessing the LLM via an API. But longer term, we need to decide whether it's feasible to host this internally with open source models, which is what the partners are leaning towards at the moment. So the thing is, you can build a baseline model really, really quickly, in about 5 minutes, in fact. And I'll show you the full code of less than 20 lines in a minute for this. So that's very convenient. And it works reasonably well for English, but it doesn't work at all for Irish. And part of the reason for that is that there's a mismatch between the query coming in Irish and all of the knowledge base and all of the web space being in English. Now, you can get better results if you go. So this is just your basic RAG system where you don't have an agent system. You don't give the system the autonomy to perform its own searches. If you do that, if you do let it go, if you give it a search interface, a search API, you can do better. But then you're not constraining the output with your knowledge bases, which is the whole idea. Also, it takes a little bit longer to develop, about an hour. But so what we've done now is go the customized RAG route. And when you do that, when you spend a lot of time customizing the RAG approach, engineering your prompt, etc., then you get quite good results. So this is all of the code we needed for the first of these 3 versions of RAG. I'm not showing the imports and the installs, but apart from that, this is all that was needed using LangChain tools out of the box. And the output that produced, I'm showing you 3 examples of here. So a simple question like, how can Dublin City Council help me find a home, gets a reasonably good answer out of this very simple baseline system and a pointer to the correct websites to look at for more information. Now, what happens when you ask the same question in Irish is something that's not as ideal. So I've put the translation, it's the same question, how can Dublin City Council help me find a home? And then the answer in Irish, I've translated down here, starts with Dublin City Council can contact you first by phone or email, and it gets worse from there. So it's not what we want at all. So how do we make it work for Irish? We go down the custom-built route, and then you get a really quite sophisticated result for both languages. And if you have a look through the answer here, it's nicely structured, it's nicely formatted, and this is how it comes out of the model. There's 0 post-processing involved here. It puts in the links, and I went through it all with a fine-tooth comb, and it's all correct. So this is quite impressive for a system that takes certainly less than 5 hours to put together. Now, moving on to our second case study. This is an academic publisher, a large one, and their core business is facilitating the publication of research findings via journals and books. Now, they've had AI as part of their company strategy for quite a while. So they've used it for recommender systems of various sorts, search, information extraction, and UX optimization. But the leadership is very wary of LLMs and of neural systems in general. And that is part of the reason why we can't name them here. It's also part of the reason why they didn't give us evaluation results, as we will have in our third case study. But so the product is a new feature to be added to a reviewer recommender. And one of those helps editors select suitable reviewers for newly submitted manuscripts, and is trained on historical decisions taken by editors. So the aim in the new feature to add is that so the recommender by itself aims to identify reviewers with a publishing and reviewing history and a profile that fits the manuscript under consideration, as well as the journal. And so the challenge for the product for this feature is to reduce the amount of time that it takes to recruit reviewers. And that's really important because they face an astonishing volume of submitted journals per week. They have 20,000 papers submitted every week, which means you need 60,000 experts to review, which probably means you need to send out 3 times as many invites to get that many reviewers, optimistically speaking. So it's a huge volume they're facing. So the idea is to increase both the quality and the speed of the editor decision, the selection of the reviewers, as well as the likelihood that the invited reviewers will say yes. And so the idea is to use Gen AI to generate explanations on the basis of the reviewer recommender output to help editors focus on the most relevant signals, as well as incentivize those reviewers to engage. They put together an internal team consisting of their data science team with input from subject experts, so these were the editors in this case, and UX support. And they started out with some quick iterations over different formats for these generated explanations using historical production data, and these were continuously qualitatively evaluated by the experts, and their feedback was collected for the next iteration. Once they had a stable offline proof of concept system, they collected another round of feedback, a final one from a fresh set of experts. So what's happening under the hood is that they're interpreting the candidate reviewer recommendations with a SHAP approach, which calculates the contribution of the K most influential features. And they put that together with instructions and the abstract of the manuscript authored by the candidate reviewer that most closely matches the submitted manuscript. They put all of that in a prompt, plus an example of what the input and output should look like, into the prompt. And then one version of this prompt is used to generate a very short narrative for the editor, summarizing the reasoning behind the candidate recommendations. And then another version drafts a personalized invitation letter to each of the candidate reviewers for explaining why they've been selected and including even citations of their work to justify why they've been selected. So this is what the system looks like. In blue here we have the system, the reviewer recommender as it was before, and the orange is the Gen AI extension. So you can see how the input from the existing system feeds into first the model interpreter and then into the prompt, and also the search results, which tell you which is the most similar manuscript, among other things. And then that feeds into the generation of the explanation for the reviewer recommendations, as well as the draft of their personal email. So currently they are integrating this with their live system. Once it's live, they will test on a small amount of traffic and observe the live behavior, collecting qualitative feedback all along the way. And once the system behaves as expected, as they wanted to, then they will move to A/B testing with a large part of the traffic. And again, continuously collecting qualitative feedback. So they've shared these key learnings with us. I asked each of our case study partners to share their key learnings. This is what they said. They think that the continuous involvement of subject experts is invaluable at every stage during development to improve their systems. And this one, the second bullet point, I'm quoting this verbatim because I thought it was quite nice. Product development using LLMs is wonderful. Iterating on system design and subsequent user testing can be done in incredibly short cycles. So if you know what this used to look like, it's an incredible speed up. Of course, it comes with lots of downsides, which they didn't mention, so not in this context. Now, in terms of system safety, the way they see it, but as I said earlier, they didn't give us any evaluation results to back this up. But they say that they find the output to be controllable enough in terms of hallucinations and other semantic faults for their purposes. So the way they control it is through providing detailed input. The more detailed, more specified the input, including those SHAP features from earlier, the more they feel they can control it. So they see the safety risk here as limited. But it's important to add that we don't know what the evaluation numbers are behind the scenes. Also, being publicity shy about their AI work, Again, we're not naming them. They wouldn't tell us what their bias figures look like. In review recommendation, that's very important in an academic context, because we know that you will not find a publisher, an academic publisher, that does not have a bias problem at all sorts of different levels. So we don't know what's hiding here behind this statement. Okay, finally, third case study. This is Trivago. They're happy to be named. And it's about their new hotel highlights feature. So this is something everybody can look up and interact with. It's quite an interesting one. So they are a global accommodation meta search website in 190 plus countries and 31 languages. They've used AI from the start. They are a tech native company. And they've used it for accommodation ranking, image tagging, accommodation matching, as well as generating accommodation descriptions. This particular feature, hotel highlights, is integrated into their search processes. So you see it among the search results. We'll see an example in a minute. So this aims to generate concise accommodation highlights derived from reviews and accommodation descriptions. And the idea is to capture the distinctiveness of properties in those highlights. So the output they're aiming for is up to 6 1- to 2 sentence summaries, each of a unique selling point of the accommodation. Now, this is the example I promised. This is a set of search results for New York. So we're going to look at the first one here, 45 Times Square Hotel. The ultra short summary is great location, a new enclave. And if you click on that, you can get expansions of each of those, which tell you a little bit more about what they mean by it. So great location gets expanded to guests love the convenient location near Times Square, for example. If you click on it again, you get all 6 highlights that are generated for it. So what they're doing under the hood is also LLM prompting with a very carefully engineered prompt. They went through quite a lot of iterations on that one to obtain the candidate accommodation highlights. And those are then passed through a sentiment classifier, or rather a bunch of them, and a theme labeler, on the basis of which they then make the final selection of the 6 highlights. They access their model via Google Cloud APIs, and they say they are fully able to protect their data. Now, internally, they put together a mixed team of data scientists, software engineers, product managers, product designers, and some UX people. And they evaluated these 2 models, which were feasible for them, ChatGPT 3.5 and Palm 2, on 25 prompts, and they got some quality scores for those from human assessors. They also looked at the token limits and the data sharing agreements, and in the end they decided on Palm 2. And then intensive prompt engineering, assessing different prompt types, arriving at a final design of summarizing the task instruction, generation criteria, reference examples, multiple ones. We'll come back to those in a minute in the learnings, input content, and output highlights. Now, they conducted a whole bunch of internal evaluations, iterating over quality assessments. And then finally, when they were happy with the internal assessments, they went to external assessment for semantic correctness. And they found that in 53% of all cases, there was no semantic divergence. In the rest of the cases, there were either hallucinations or contradictions or both. Now, I'm just going to go quickly, oh, no, that's not on. Quickly back to here. You can't read this, unfortunately, but what it says here in this tiny print is that this content is AI generated and may not be 100% correct. Now, this is what those evaluations confirm. Now, the current status is that the hotel highlights is very visible in search results. The feature has been significantly scaled recently. The company sees it as a big differentiator, driving engagement and improving search results, search experience. It's currently under active development to improve over those accuracy figures, as well as the distinctiveness and relevancy. Now, these are the key learnings they gave us. One shouldn't see LLMs as a panacea that do all the job for you. You need to have a very clear objective and a specification of what you're optimizing for. So, for example, engagement, but there are many other possibilities. And very important for them was high quality examples of good and bad outcomes. So what constitutes not only a good set of unique selling points, but also in terms of how the users react to them. They say you need to leverage diverse data. That is very important to get a representation of content, so you have a representative enough sample for bias mitigation, as well as getting better visibility on variation in outcomes. I think that's a very important point. And human evaluations, again, as in the earlier academic publisher example, seen as very important. You iterate over well-designed human evaluations. You need to evaluate on multiple dimensions, plan those carefully with a focus on task design, training, calibration, and measurements. So we've seen these 3 case studies at different stages of their journey, their Gen AI journey, and with different kinds of learnings, and a representative sample also of companies and organizations that are AI forward and are not shy in talking about it, Trivago being an example, and others that are far more reticent and worried about publicity. So at this point, I'm going to hand over to Miqdad, who's going to tell you about the remaining 2 case studies, and also introduce the offering that aiExplain can make. Thank you, Miqdad.
Thank you, Anya. All right, how's it going, everyone? My name is Miqdad Dali. I am a product manager at aiExplain, working with the AI solutions team there. So today I'm going to be talking about an industry journey of generative AI solution development. So the agenda for my talk, first I'm going to start with a company background. What is aiExplain? What is it exactly that we do? And then I'm going to jump over to the first case study around an AI-powered insurance agent. Third, I'm going to have another use case where collaborative AI was a need to develop the solution there. Lastly, highlighting on a very high level the AI progression, how AI solutions have progressed throughout the last 25 years. And lastly, the conclusion and the takeaways. So starting off with who's aiExplain, what is it exactly that we do? So aiExplain is an end-to-end AI solution development platform that is no-code, low-code, that is integrated on top of a marketplace. That marketplace is for AI assets, namely models and data sets. The marketplace boasts over 40,000 AI assets, both proprietary and open source. So in the realm of LLMs, you would find the open source models that similar to the Llama 3s out there, the Mixtra models, and you will find the proprietary models such as the GPTs. So we are on a mission to democratize AI technology, making it widely available, usable, adaptable, and understandable. So as I just mentioned, we have tools that users can use or facilitate to benchmark or evaluate the performance of different models against each other, to fine-tune pre-trained models, as well as to connect different models to build pipelines. And we have standardized all of the models across the board, standardized the API so you can connect an OpenAI model to a Google model, for example, without any code. And this is the aiExplain platform in a nutshell. Now, one thing is, not everybody has the particular skill set to browse through the platform. They don't understand what are the AI models and the technologies out there. And there is that form of gap between a user problem and the technologies out there. And kind of following up to Draco's point around the need for certain new skill sets, one very important skill set is solution architecture. So we have actually developed also an AI agent named Belesprit that is able to connect with our AI platform and use all of those tools under its disposal to translate the user's problem, where a user can go and talk to Belesprit saying, here is my business problem, and Belesprit will go on as a solutions architect, get all of those different components and connect them in unison to build the AI solution and to deliver it to the client. Now, Belesprit is not perfect. So there are certain instances where Belesprit, there's a missing model, for example, in the marketplace that Belesprit needs, or the problem itself is a little more complex that Belesprit cannot address it. That's where Belesprit as an agent is able to connect to other human agents in the form of aiExplain solutions architects who can then use the platform to develop the solution for the end user. Other channels that we have in the company, which are internal channels, so we have customers coming directly to us asking for an AI solution. So we kind of deploy our solution architects to build and deploy their solution on Explain. How does the AI solution journey look like for us? One very major methodology that we follow is working backwards from the goal. So the steps that we take, we start with the ideation and the scoping. We ask the questions around what exactly is the business problem, and we try to translate that into the requirements, or what are the technical requirements, the business requirements, what models and components we need to use, and how to integrate them. Finally, we go to the solution development. We then follow it by the pilot testing. So one thing about AI solutions is you usually start small and then you kind of scale. So we start primarily with a pilot, and after the pilot is approved and validated, we then take it to a full-scale deployment. And after the deployment, there's always the element of solution improvement. So I'll give you an example. Recently, we had certain solutions that were deployed using Llama 2, and our clients came to us and say, hey, Llama 3 is out. We would love to use Llama 3 for our solutions right now. And our platform was able to offer that very seamlessly by just swapping it with the click of a button. So now I'm going to take you over a case study we have worked on, which is an AI-powered insurance agent. The business problem here is the unfortunate event of a catastrophe in the form of a hurricane or a flood. Insurance agencies are flooded with claims for insurance. And the solution was needed around improving the processing time and as well as the experience for the claimants who are submitting the claims. So the KPIs that we were, that the customer was actually wanting us to address is the claim processing time, the claim assessment accuracy, the claimant satisfaction score, and fraud detection as well. So when we're talking about the requirements for this particular solution, from the technical side, we had the integration. The customer wanted us to integrate with their already existing infrastructure and system. As well, this is common across most of the use cases that we work on. Second, we have the accuracy. We had certain acceptance criteria for the accuracy that we had for the KPIs. Third is scalability. We needed to handle over 600 concurrent claims to be processed at the same time. And on the business side, we had cost requirements, timeline requirement, as well as security and compliance. Of course, this is very important in the realm of data governance and data privacy. So the proposed solution came in the form of an AI agent. Because it was a very wide kind of problem to solve, one very efficient way to solve it is through agentification. So the AI agent, to give a definition to what an AI agent is, it's an autonomous AI system that connects with its environment of AI tools, humans, or other particular assets to work in unison to deliver the solution. And agents are also self-taught, so they actually learn and adapt to what would be the most efficient way to reach that solution. So the agent itself will be able to handle intent-based questioning with the claimant, so asking the right questions to help them facilitate the filling the form. So instead of going and filling a form for the process, you converse with an agent. It knows what is exactly missing from your claim, and it asks you the right questions. Second, fraud detection. Because of the volume, some instances you might experience fraud there. We have images and satellite analysis. I will dig a little deeper into that in a minute. Information logging and filtering. So as I've mentioned, connecting to their existing database to plug in the new claims that are submitted and to actually also use RAG to get information from there. Comprehensive claims details, so summarizing for the insurer or the agent there, and also decision-making support. So I'm going to get into one element of that, which is the image and satellite analysis. I don't have the time to cover all of those mini projects within that solution that we worked on. But for the image and satellite damage assessment, we had to kind of train actually 5 different models in 3 different criteria. So the first is in terms of roof inspection. We worked on training a model to do roof shape classifier and roof material classifier. For property structure, the size estimation as well as a structure detector. So if it's a fence, a pool, etc., or a building. And lastly, the damage inspection, and that is the output of the model that utilizes all of the other outputs of the other models to give you the damage assessment and an estimate about how much would that claim actually cost. So one thing that was a challenge to us when we started is, the data wasn't there. It's a very niche kind of type of data. So what we had to do is we had to invest in building our own labeling infrastructure to capture that data. Now, the labels of interest that we had were the roof shape, roof material, the structure, the size, and the damaged area. And over 7,000 satellite images of damaged and undamaged properties were labeled for this particular project. Here is basically the criteria for the shape of the roof. So we had 4 different classes. We achieved an accuracy of over 90% amongst those. And here we have for the roof material, we had 3 classes and we achieved over a 95% accuracy for those. For the property structure, so that's mainly for the size estimation of the property, and also telling if this is a building or if this is a pool or a lane or any other structure that was used. So here is basically how the model particularly worked. So here you see in the pre and the post. The pre, there was no damages to the property, and the post, you can see some damage to the property, and the model was able to identify the damages. So here's a short demo around the actual solution using the full agent framework. And I'm just going to play it. So first, we have the claimant side. So there's a portal that the claimant can log in. They can actually see what claims they have in progress and what is approved and what is not. And then they can upload any images as part of their claim. And they can converse with the actual insurance agent. They would be asking all of the right questions and consequently filling out the form. And you can see at the top, there is the filing progress. So if there is missing information, that bar will not be full until all of the information is there for the claimant, for the agent actually to say, okay, that's enough information, thank you. We're just going to hand that out to the actual human to do the evaluation. Now, from the agent side, the agent can here see all of the claims that were submitted. He can see the readiness of the claims. So there are claims that would be still in progress. If there's a claim that's ready to be reviewed, the agent can check it out. The AI agent is going to actually give a summary around the claim to add all of the necessary information. And for the satellite side, based on the address that's provided as part of the claim, it taps into satellite imaging to kind of get a preview of the actual structure to validate whether this property has been damaged the way that the claimant has submitted or not. And it's also able to provide the actual assessment in the form of a cost estimation. So here you can see the output of the model. You can see the roof material, the composition, the shape, etc. And the human can actually just go ahead and review that. And here you can see the claim summary. You can also see the cost estimation, and you can see also the fraud detection. So based on certain algorithms with the history of this particular applicant, as well as the language and other inconsistencies, it can detect whether this is a fraudulent case or not. After that, they can actually, after review, they can accept or edit or review the process. All right, so the challenges and the current status. So right now in this particular project, we are in the full-scale implementation phase. The first challenge we faced is, of course, in the ideation step, identifying what is the most impactful use case within that particular sector. And the way that we kind of address that and explain is we actually employ industry specialists very early on in the process to actually help us validate the business idea. Challenge 2 is finding pre-training data. So unless you are training a classifier for leaves, data doesn't grow on trees. So what we had to do was investing in high quality data management practices, as well as getting external resources to help in the data annotation. And the last challenge is managing expectations. So one thing about AI solutions right now is there is a very high level of expectation around solutions, especially when you're talking about a pilot. So basically, in the early stages of conversation with the client, it's very important to manage the expectations of the pilot and define also the scope of the pilot and the full deployed solution. So now I'm going to go over the second use case very, very quickly. So the second use case is talking about Moxie. So Moxie is an AI robot developed by a company called Embodied. It is the world's first conversational AI robot for children. Now, given that this is a very critical mission, there are 3 critical requirements that were dictated by Embodied. The first comes in the form of content moderation, of course, to ensure the safety and conversation with children. You don't want Moxie to have a conversation with children around how babies are made, for example. The second is data governance, so ensuring that the children's data is private and secure. And lastly, the speed to ensure that the conversation is as smooth and as fluent as possible with the robot and the child. Second, we have a second player in this solution comes in the form of infrastructure. So Grok is a company that manufactures LPUs, or language processing units. And the LPU is basically designed to offer very high-speed inference of large language models. Now, based on Explain's benchmarks, Llama 3, 70 billion, that's deployed on Grok, and another is deployed on AWS Bedrock. On Grok, it's 5.2 times faster, and it was 2.4 times faster than GPT-4. So you can see the collaborative landscape of AI here. We started off with the high-speed infrastructure of Grok. We had Explain for model serving and solution architecture, and finally the end-user application from Embodied. During an interview in CES 2024, Jonathan, which is the founder of Grok, actually made a very nice statement just summarizing this beautiful collaboration. We're each representing a different portion of the stack. We, Grok, make models go fast. Explain provides the quality and the selection of the models. And with Embodied, it's bringing that magic to the end user. You are starting to see the maturity of AI now. A year ago, I don't think any of us would have known how to find each other. So that kind of summarizes the collaborative landscape of AI. Quickly going over the AI progression. Throughout the last 25 years, we started with applications in the form of predictive models and classification models in classical machine learning and big data. And now we are moving towards agents and fully autonomous kind of large language models. And over in the top, you can see actually the progression of the compute as well that is happening in parallel to this. And they are going both hand in hand right now. So in conclusion, the fast advancements in AI capabilities and compute highlight the immediate importance of responsible AI development. We are going too fast, and sometimes it's very important to kind of ensure that we take precautionary measures for safe AI development. Second, data is the new gold. Ensuring proper data governance in AI solution development is very critical and very important. Third, AI projects are progressive. So as I've mentioned, we start very slow. We started with a pilot, and then it goes into a full-scale project. This is also due to the lack of trust that certain people have. And the other element is people still don't know what AI is capable of and how they can translate the technology into a business use case. Fourth, we have the collaborative landscape. There's no company that can do it all. You are seeing collaborations left and right in the AI space because of that lack of power to be able to deliver everything all at once. So collaboration is actually very, very important in the AI landscape. And finally, the dimensions of AI solutions can become limitless with AI agents. And then that is the direction that we are taking with Explain, where we are going to work to enable everyone to build and create their own agents on the platform. So that was all, and I will pass the mic back to Anya. Thank you.
Okay, thank you, Miqdad. If you stay on stage for some questions, we have time for a very small number of questions, and we have one over here already. So you can ask about any of the case studies we presented. Please go ahead. Did you want to ask a question? Yeah, you. Oh, yeah. You raise your hand. So you mentioned Mm-hmm.
Yeah, so part of the Explain network comes in the form of partnerships that we have with specialists in the data annotation field. So we have tapped into certain APIs that allowed us to find satellite images around data at particular dates, and we were mapping those with catastrophes that were happening. So we kind of did the annotation of pre-catastrophe and post-catastrophe to be able to assess the damages. We kind of fed that into insurance agents who were assessing the damages and how much would those be worth for all of those instances. Mm-hmm. Yes. So in essence, the AI agent would be able to. The claimant doesn't know what are the necessary information that are required to fill an insurance claim in a lot of cases. They're average people like us. And a lot of people even don't bother going through the process to begin with from how complex it gets. So the AI agent is able to kind of grab a thread of a conversation around the claim itself and move forward with that until they get that information from the claimant. Because if they start on asking with, here, give me this information, the claimant themselves might not actually know how to give that information.
Thank you for the question. Can I remind you to please say your name and affiliation very quickly and to speak up? It's a bit difficult to hear at opposite end of the room. Question
Hello?
just here. Yes, please.
Hopefully a very quick question. The Dublin City Council example earlier on answering questions in Irish. Why not translate the question to English, answer it in English, and then retranslate back into Irish? Is there something wrong with that?
No, not as such, but you introduce an extra step, you introduce a pipeline basically. So if your translation isn't good in the first place, then it will affect the answer generation. So these days we find that an end-to-end system overall actually works better. But in other contexts, for example, we've recently built a data-to-text generation for Irish, data-to-text generation system where we found that it works a lot better to generate the whole thing in English first and then translate into Irish. So in some cases it does work better, but in this case we found it doesn't.
Yeah, just to add to that also, the three components usually with AI solutions, you have cost, latency, and quality. In some of those niche languages, it would be actually worth it to go through the route that you're kind of talking about, putting a translation engine before and after the LLM, because the LLM particularly wouldn't be well trained on that particular type of language.
Okay, thank you. And a question over here?
Yeah. Thank you. Hi, everyone. My name is Adi Bota, and I am a principal data scientist at Eaton. I have a question about the reviewing system. I was wondering on what metrics you would evaluate the impact of the system compared to the current way of assigning reviewers.
Right, now I don't have sight of exactly what they did internally, so I can't give away any company secrets. I do know that across the domain, there always are bias problems, so I'd certainly evaluate for outcomes in terms of bias. We see differences not only in terms of gender, geography, geographical location in the world, different ethnic groups. Affiliations is a big one in terms of bias. So I'd certainly start there. The quality of the recommendations is the other obvious dimension you need to assess. Is it semantically accurate, what you're putting in your draft emails and your the summary of the explanation? Did you have anything in particular in mind?
Not necessarily, but I was thinking also at the end of the process, looking whether authors happier with the reviews, whether the reviewers happier.
That's a very good metric.
The reviews better and the entire review process.
Yeah. Certainly, I know that they're looking at engagement rates. Do they reply at all? And acceptance rates, do they accept the invitation? And all of those. But I don't think there's any system that can keep academics happy with the reviews that they get. Okay, do we have time for one or two? One more question. Yes, please.
Thank you very much. Related to your last showcase, the
Miqdad.
No, sorry, the reviews.
Oh, okay. Right, sorry.
You mentioned there is a little disclaimer that this text is generated by AI. Do we know how this affects readers' perception of reliability, accuracy, etc. of the text?
Their perception of it, you mean the end users that will see the hotel highlights as part of their search results? I have no idea. I don't think they've looked at that. It intuitively probably does, as it should, because that's what it's there for. And as we saw from the evaluation results, we should be skeptical. To be perfectly frank, I was a little bit surprised. They were happy to share these numbers and happy to go to production with those numbers, but there is that disclaimer. So as we all get used to encountering more and more AI outputs in our daily lives, we have to be, first of all, serious. The providers have to be serious about warning us about it, and we have to be serious about reading the warnings and changing our reactions to them accordingly, I think. I'm very aware we've had questions from lots of men, so I'd really like to hear a question from somebody who doesn't identify as a man, to finish off. Sorry, guys, I'm putting you on the spot, but it would be nice. No? One last question? Someone? Yes, please. Go on.
So, yeah, I think very interesting social case here. I just thinking more about how you operationalize it for enterprise apps with like safety and compliance and data protection concerning the suggestion and resources.
Do you want to take that one, Miqdad?
Yeah, sure. I think it has to do a lot with also the client that you're speaking to. There are certain clients who really don't take data privacy or security into consideration. We have to remind them of that actually sometimes. In Europe particularly, they're very iffy about data, and that's a good thing. GDPR is there for a reason, and we are working hard to maintain our compliance to GDPR and other forms of SOC 2, for example, is another compliance that we work on. So in some instances, there's the customer who's kind of, or the client who's being very iffy about their data privacy and the compliance around it. And when that is not present, we do the other way around. We're the ones who start reminding the client, hey, you keep your data secure. Data is the new gold. We ensure them about the importance of that, and I think that's a takeaway that I would hope a lot of you would take, is to be a little more iffy about the use of your data, not just in an enterprise setting, also in a consumer setting when you're using all of those AI tools and applications out there.
Right, thank you. I think we'll have to leave it there. There'll be more opportunity to talk to Miqdad and I. I've brought those systems I mentioned for the council along with me if anyone wants to have a look at my Colab notebooks. But for now, we'll leave it there. A huge thank you to Miqdad for coming over and talk to us in person. Thank you.